Okay, we're going to look at our problem here on projectile motion. Problem is a soccer ball is kicked 7 meters per second at an angle of 30 degrees to the ground. Okay, so look, what is the height that this ball reaches? Okay, so this is what we want to find out here. What is the height? What is the height? Now, the first problem here is we can't work out what the height is using the vector that we've got there. What we need to know is the part of that vector, or the component that is acting in the vertical direction. Now, to do that, we're going to have to use trigonometry. So the first thing I want to do here is I want to draw a reasonably accurate triangle. So I want to, here we go. I want to draw the components. Here is my horizontal component, right? And here is my vertical component. I'm just going to label them. There is the horizontal component, and this is my initial vertical component. Now, I'll put the angle in here, 30 degrees, and we've got, I've got to label the magnitude of this. We know what that is, the hypotenuse here. It's 7 meters per second. Okay, so if we want to work out the height, horizontal velocity isn't going to actually mean anything to us. The vertical velocity is what is going to affect how high it goes. That it means that, you know, the faster it's going upwards, the higher it's going to go in the air. The smaller it is with its vertical velocity, the less distance it's going to get in the air. So we want to work out what our initial vertical velocity is. To do that, the first thing we've got to recognise here is this is the opposite, okay? And this is the hypotenuse. So we know an angle, we've got the hypotenuse and the opposite. We want to be using sine, Projectile, using sine here. So just let me shrink this down, put it up in the corner. Okay, so here we can say that sine theta equals opposite over hypotenuse. Or I'm just going to move the hypotenuse out to the other side. I get that opposite equals sine theta times hypotenuse. In this case, the opposite is my initial velocity, and it's going to equal sine theta sine 30 times the hypotenuse. Hypotenuse 7.0 meters per second. Okay, for those of you who know off the top of your head, sine theta is 0.5. Going to times that by 7, and here 3.5 meters per second. Now, I want to go back to this triangle that I drew. When I drew my initial triangle, okay, here it is here, what I wanted to do is kind of draw it to scale as best that I could. So I made sure that the angle here was an angle that represented about 30 degrees. This means that when I look at my answer now, which is 3.5, and I compare it to what I would expect my horizontal component, my vertical component to be, I can see that 3.5 is a really realistic answer. Okay, because that looks about half the size of my 7 here. So I'm really confident at the moment that this is the answer. Right? So now we can go on and do the next part. The next part is, okay, we know the initial velocity. Can we find out what other things we know about our vertical components so that we can work out the height, or what we would call the distance vertically. Okay, so just going to move this up a bit. Okay, and up here. Okay, so just let me continue here. We've got, so if we were to write down what our vertical components were, now I'll just go over what I don't think I've spelled vertical right, but no worries. So what I mean by vertical here is all of the quantities that relate to the vertical motion here of this projectile. So we've got, for a start, obviously, the initial velocity. That equals 3.5 meters per second. Now, the next part that we can do is what is the final velocity. Now, this is, we have to be really careful here. If we're looking for height, then we need to understand or remember that the projectile, when the projectile is at its highest point, the vertical component of the velocity equals 0. That is, it's stopped. It has no vertical motion at that point. It's slowed down, and it's about to change direction and start to accelerate down. Oh, it's going to continue to accelerate downwards. So here's my initial velocity. My acceleration, of course, is 9.8 meters per second. Distance, that's what we don't know. And also we don't know at the moment is time. But we've got quite a selection of equations that we can use here. So we can usually, using the selection of kinematic equations we have, we can work out what the distance or what the time is. Right, okay, so let's just put this up here for the moment. Let's get back to kinematic equations. So when I search through my kinematic equations, what I want to do is find the one that has, they usually have 4 values, and I want to find one that has the value we want to find out, which is D, and the other 3 values we know the answer to. So this equation here, which is the final velocity squared, equals initial velocities plus 2AD. Okay, so this is the equation we're going to use. Not in the form we want it. What we want to do is put the distance as the subject of the equation. So I'm going to do the opposite to bead mass here. I'm going to start by moving everything to the other side apart from the distance. So, and I start with my subtraction and my addition. So the VI squared is added to AD, so when I move it to the other side it becomes subtraction. So I get VF squared minus VI squared equals 2AD. Right? Cool. So I'm going to continue to move everything to the other side so that distance is by itself. What I'm going to do now is move away my 2A from the distance. It's multiplied to the distance at the moment, so when I move it to the other side it becomes division. So I get VF squared minus VI squared over 2A equals D. So there we go, we've got the equation in a form where we can use it. There we go. Fantastic. So again, let's just shrink that down, put that up there. Okay, put it there. So let's put our values in. Distance equals VF, okay, that's pretty easy, 0 minus VI squared 3.5 meters second negative 1 squared divided by 2 times negative 9.8. Remember, our 9.8 is always negative, and whoops, up here, I forgot to do that up there. Okay, so there we go. We just pop that into our calculator, and we get the answer. Answer 0.625. Now I've got to work out the units. Okay, so if I look at the top here, I've got meters per second. Okay, so let's just put this here. Meters per second, negative 1, times meters per second, negative 1, over meters second, negative 2. Oh, look at that. Okay, so seconds, I've got a second negative 1, second negative 1 here, so that cancels out with second minus 2 on the bottom. Meters cancels out, meters cancelled out, so the unit I'm left with is meters. I mean, that was pretty obvious anyway, because as a distance, that's our height. Okay, 0.625. The answer isn't perfect because if we're doing NCA physics, they ask us to put the answer in the correct number of significant figures. And to work that out, we look at our first information that was given to us, and that's at the top here. Okay, and notice that both these here, so this one here is given to 2 significant figures, and that's given to 2 significant figures. Because the data was given to us at 2 significant figures, we need to supply the answer in 2 significant figures. So here, 0.63 meters. Wunderbar. Fantastic. There we go. That's the answer. All done. Okay, and those are the steps. And here we go. So